My name is Caitlin. I'm the customer service manager at Kwik Lok, as well as the vice chair for the Washington chapter of Women in Manufacturing Board. This is our first event in our new Lunch and Learn series, and we had almost 60 people register. So I just wanted to say, thank you so much to everybody for spending your hour with us, learning about sustainable packaging. Our next Lunch and Learn topic is mastering conflict resolution to take your leadership to the next level. And we're planning to host that on 8/26. So save the date and we'll be sending out more information later. For this event, we are requesting that you please stay on mute, but feel free to enter any questions you may have into Slido, which is a platform we're going to introduce here shortly, or the Zoom chat, and Vicki will answer the questions either throughout the presentation as she has time or at the end during a Q&A session. She will also have some polls throughout her presentation, so have your phone out and ready to scan the QR code on the screen. Please note that this event is being recorded and we're going to upload it to the Women in Manufacturing Washington chapter YouTube at a later date. And without further ado, I would like to introduce you to our presenter today. Vicki is the Sustainable Product Development Manager at Kwik Lok, and she is here to explain the science behind packaging materials, their functionality and trade-offs, as well as show how Kwik Lok navigates the complex global landscape and the significant strides the company is making with their small bag closures. Goodness, that was a mouthful. Vicki, you can go ahead and take it from here. Thank you.
Thanks, Caitlin. Thanks for having me, and thank you everyone for showing up. I'm glad to be able to kick off this Lunch and Learn with WiM, and I hope you learned something new today. So, as Caitlin mentioned, I'm working at Kwik Lok, and we'll be talking all about sustainable packaging today. All right, so if you have not used Slido before, this is a chance to get it ready on your phone, or if you're on your computer, go ahead and scan this QR code, or if you like, you can enter slido.com and have the code ready that's listed here. So this will be a chance for you to submit questions, and then we'll also have a couple of polls during the presentation. So that'll give you a chance to participate. So I'll give you a minute here just to make sure you can enter and that you have that ready for the future. What you should see is on the right side, there'll be two tabs, a Q&A tab and a polls tab, and those questions will pop up as we get to them. All right, if you haven't already entered, we'll have a chance to do that later, but we'll start then with an outline of our talk today. So I wanted to start by talking about some packaging materials, very basic science, trade-offs, some of the sustainability aspects of them. Then move on into environmental impacts and some of the ways that we can compare different types of materials. From there, I also want to go into sustainability goals. There's different ways to approach sustainability, and that's what we'll cover, some of the differences. And then at the end, I'll talk a little bit about messaging and labels that we can put on products. So if you're not already familiar with Kwik Lok, I wanted to give a brief introduction. Kwik Lok is a family-owned business headquartered here in Washington in the Yakima Valley. And if you don't know our product, you probably have it in your house. It's the little closure that you'll see on the end of a bag having your sandwich bread. You might see it on some produce, like in this avocado example here. We have lots of different variations with thicknesses and shapes. You can have a label attached. And not only does Kwik Lok manufacture the bag closures, we also design and assemble the machines that place them onto a bag. So it can be on an automatic commercial line closing those bags in large quantities. So my role at Kwik Lok is to try to answer the question, how can Kwik Lok closures be more sustainable? We are a small packaging component, but we want to make sure we're doing our part and that we can be, um, uh, we can have the least environmental impact as possible. So I want to first take you to a scene. So we're now moving into June. We just had Memorial Day weekend. You probably spent some time outside. And after a while, you're probably getting thirsty. You enter a store and you see in the refrigerated aisle all their tasty different drinks. If you're a consumer, you'll look at this and you're probably thinking, which type of drink am I in the mood for? Is there a brand I've tried before and I like? Am I thinking about sugar content? But I want to switch our angle a little bit here and say if you were a packaging engineer or manufacturer, maybe you're a recycler, you're going to look at this aisle a little bit differently. And what you'll notice is not just the contents of all these bottles, but what kind of containers they're in. And this is, of course, an allusion to all the different materials that we're going to be talking about today. So you'll see on the bottom, we have our aluminum cans. Moving up a shelf, we'll see glass with the liquid that you can see inside. You'll see capped plastic bottles, and you'll also see a little bit with some paper cartons that have been lined and also contain your delicious drinks. So what I'll do next is I'll go in a little bit into each of these materials, talk about some of their features. So, given that my PhD is in chemistry, I think it's appropriate to include the periodic table, but I'm not going to be technical about it. Just very basic that each of these squares here represents a unique type of atom that all of our physical world is made from. So one way to categorize these elements is you can see here by color, we have metals in blue, non-metals in green, and in between we have metalloids in orange. Metal packaging is most commonly aluminum that you can see in the red square on the right, or iron, which is the main component of steel, in the middle. And as you go down the periodic table, these elements are heavier and you'll be able to look at the different aspects of them. So I wanted to mention some of the pluses and minuses of using metal packaging. And first starting with their functionalities. And we know very well from the canned goods that we buy that it is quite protective. You're not going to have smells coming through those cans. You're probably not going to have things spilling unless you really puncture it. And metal will last a long time. However, it's not completely indestructible, and iron in particular can corrode if it's not treated ahead of time. And it's also heavier than other types of packaging materials. If we look just diagonal from the aluminum symbol, Al, is carbon-based. That's near the top. Those are lighter materials, and that's what some of our other packaging options are made from. Given that this is a talk about sustainable packaging, a couple of aspects of sustainability is that metal is highly recyclable. You really just need to essentially melt it down and you can reuse it all over again. The downsides is that if we are taking metal that isn't recycled and out of the ground from the ores, there are mining impacts to think about too, especially maybe in geographies where there aren't strong regulations that protect employees or the environment. We want to make sure that the process of mining and extracting things from the earth doesn't leave detrimental effects. Moving on to glass, this is primarily made out of silicon dioxide, and the formula is SiO2. And the structure that you'll see on the top left here, we have 2 oxygen atoms in blue for every silicon atom. And they're arranged here in a disorganized network. The technical term here is amorphous, and that's what makes up glass. Of course, we can add other components to it for different kinds of glass. We can color it, but this is the main ingredient. If we look also again at functionality, this time of glass, we know that is quite inert. So you're not easily going to, say, stain it, or it's not easily scratchable. And so it really lasts a long time. There's a reason why when I go to an antique shop, there are a lot of glass items out because they really do last a long time. On the other hand, this means that um, compared to other materials, it's quite fragile. If you drop it, you won't necessarily see it again in one piece. And so this usually means that the glass is thicker, and so that makes it a heavier packaging item. And this has effects all throughout its use, particularly in transportation. So for the same amount of liquid, say that you have to package, you'll have to have more weight in packaging, and that'll mean you got to use more fuel for that transportation. Sustainability wise, because glass is so durable, it can easily be reused. It can also be recycled, like metal, melted back down and reshaped to new products. But however, like metal, glass also is pretty energy inefficient. This material needs to be heated to around, excuse me, around 1,000 degrees or more in order to reprocess it versus something like plastic, which might be in hundreds of degrees. So we have to think about where that energy is coming from and what are the impacts there. Plastic, which is my specialty, is usually made from synthetic polymers. So looking at the top left, we have a couple of ways to draw an example of a polymer. So here we have carbons and hydrogens connected in this repeating pattern. You see the three-dimensional ball and stick model here with carbon in black and hydrogen in white. And imagine this, instead of being a fragment that you see here, it's thousands and thousands of units long. And this is the basis for two common plastics that we use, number 2 and number 4. It's called polyethylene, the PE. And the interesting chemistry is that it doesn't have to have this structure. You can have different kinds of building blocks, but the basis is we have many repeating units that are very long and structured in different ways. If we go back to functionality, plastics are a lightweight material. And so this is one of the things that's great about it. Not only is it lightweight, but it has properties that you can make it very thin. So we not only have rigid bottles like these, but we can make pouches and flexible bags just by adjusting even the gauge of our materials. And its versatility, not just from the use, but the ingredients that you add and the types of chemistries that you can do, makes it quite attractive, as you can make different types of things with it, coloring it, making it different protective qualities, and things like that. Compared to metals and glass, it does degrade more quickly. And so, for example, in a recycling process through many heat cycles, these chains don't always keep their length and they can start breaking down, and that'll change their properties. But regardless, it still can be recycled. Something we've been learning about more and more recently, of course, are some of the health concerns associated with plastic. Usually these are ingredients that are added to it, but we're just starting to understand a little more about microplastics and how those are made, and what kind of interactions they have in our environment. So it's definitely something valid to pay attention to. From the recyclability standpoint, it is recyclable sustainability standpoint, it is a recyclable material, though maybe not to the same extent as other materials. And the downside is that it is fossil based. So we're taking fossil fuels out of the ground, we're bringing them up into these new formats, and we still aren't, I guess you can say, completing a carbon cycle of these materials, and we're learning more about how we can use them more responsibly. Lastly, I'd like to cover paper, or you might see it called fibers. And these are plant-based polymers. So while plastics tend to be a single type of polymer, paper has a few different kinds going on, and they have a bit more complicated structures. So if you look at the little black strands in our diagram here with cellulose, those are the individual polymers. When you stack a bunch of them together and they form together a microfibrils, many of those will then form the bigger fibers. And it's surrounded by smaller amounts of hemicellulose that you'll see in red strands here, and lignin in brown. So those are the major components, cellulose being the main one for different types of paper products. Like plastic, it is also lightweight, and with these different ingredients, depending on how you process them, the chemistry, you can make different types of papers with different properties, so it does have that versatility. On the downside, I guess, depending on your use, is that it's quite porous. So something we've run into at Kwik Lok is that paper really does like water, and that can change how soft or stiff your material is. And you may not always want that for your needs. It's also not durable, so it's a lot easier to puncture paper, we'll say, than it is glass. And so it's not meant to be around as long, but that could also be an advantage depending on how you want to use it. From sustainability perspective, that means that paper is renewable, given that it comes directly from plants. We can regrow them, we can safely discard and degrade this material back into the earth, and not have to have as much worries unless we have some kind of added ingredients in there that might not be safe. But we also have to pay attention to how we manage forests and other, if not wood sources, to make sure that we're not clear cutting, that we can have manageable amounts of wood, and that we're not having negative impacts on the ecosystem. So why don't we get ready to open up our Slidos links. So if you haven't already done that and entered the code, you're on the right page. And I will ask you all a question. So the scenario is this. A beverage company is selling a new brand of lemonade and is committing to sustainable business practices. Which type of beverage bottle do you think has the least environmental impact? So, Kaylin, if it's not already posted, if you could please make that available. And the options here are the ones that we looked at in our original aisle of chilled beverages. Is it going to be coated paper carton, an aluminum can, glass bottle, or plastic bottle? So I'll give a bit of time for answers to trickle in.
Looks like glass bottle is winning with the aluminum can in second place. Anybody want to enter their answers real quick before we move on? Okay, we have glass bottle as the winner
Okay.
and aluminum can as second. And then a close third is coated paper carton.
All right. Very interesting here. So I'm not going to give you the answer up front. I will lead you to it in ways that we can actually measure these impacts. So stay tuned. Um, before I move on, do we have any questions so far?
I don't have any questions in the chat yet.
Okay. At any point, if any of you have questions, feel free to submit those through Slido, and we can address those. All right, so then to address our question about which bottle is best, we want to be able to have some kind of measurements of environmental impacts. So I wanted to answer the question a little bit about how can we think about sustainability based on kind of our own experiences that we find. So first thing is that an environmentally friendly packaging option is not sustainable if it doesn't meet functional needs. So what this means is if, say, you do an analysis and you find that paper is a great option, but we don't use paperboard really a box for our liquids, right? It has to function, it has to do its job first before we can think about the impacts that it has. Another key point is that there will always be trade-offs between decisions, and there's never going to be a perfect solution. If that did exist, we would be on that bandwagon already making all those changes, but depending on your angle, it's going to change your answer. So this is an art installation where just depending on where you stand, you're going to be seeing a yes or no. And this is very true for sustainability. You can have the same options to compare, but with different questions, with different goals, with different metrics, you're going to be getting a yes or a no. And that can easily change as we learn new information. One way I like to think about sustainability is in these three categories pertaining to packaging. So the first is feedstock. So where does your material come from? Is it a bio-based material versus one that's fossil fuel-based? Are you using waste or byproducts that maybe don't have a use otherwise, but you're now making useful? We also want to make sure that anything we include in it is safe and not causing harm to health or environment. The other thing we want to consider is the processing. Once we choose the materials and we're making our product, what kind of resources are involved there? So for limiting natural resources, how much water does it take? How much land does it take? We want to also be able to reduce the carbon emissions throughout the process and think about our energy usage too. And then once our product has served its life and had its function fulfilled, what happens to it at the end of life? Is it something that can be recycled? Can we compost it? Or is it destined for landfill or maybe burning through incineration? How do we compare all of these things? Different materials will have different aspects. One way we can do this, is a very useful tool called the life cycle analysis. So essentially what this does is we are able to quantify and actually have some numbers so that we can make comparisons a little more easily. The way this works is we'll input different product details. So this will include things like the type of material you're working with, how much it weighs, where you are located since systems are different across the globe. And we'll put that into a software that will run some calculations. You'll set different parameters, we'll reference databases, and the output can be different environmental effects. So some examples I've here you can categorize into water, carbon, other ones. So for example, you will look at greenhouse gas emissions and fossil fuel usage. You can look at how much water is used or the potential for water pollution. Other factors could be how much mineral is used and overall human health. So there are other types of metrics that you can look at, not included here, but these are some of the ones that we can compare. So, given that we can use a life cycle analysis to compare materials, here is an example comparing these 4 bottle materials. This, at the top, we have global warming potential. So this is a measurement looking at carbon or different gases released into the atmosphere and their equivalents, and looking at the entire impacts. It says on the title, cradle to grave. So this is from extracting raw materials to making the bottle, using it, and then disposing of it. It also includes the transport. So it really takes the full life cycle of that product. So in red here at the top, we have aluminum. So the first one, ETB, is a resealable aluminum bottle that you don't see very often, but does exist, along with kind of the more classic ones that you pop open. We have a couple glass jars in different sizes. In orange, we have PET, which is a type of plastic number 1. NC in this case is non-carbonated, so that's the one we're interested for our lemonade. And then lastly, we have our carton with the kind of multi-materials. So if we are to take a look at the results of this analysis, we'll see that the global warming potential is highest for glass by a lot, actually. The PET bottle, especially non-carbonated, has the lowest. And so in between there, we have aluminum and our carton. So the folks that said glass would be maybe the best for environmental impact, this type of measurement tells us otherwise. So the data oftentimes can disagree with our own perceptions, and something like plastic that has quite a negative view can be the least impactful option oftentimes. So why don't we also look not just at global warming potential, but a few other metrics. So here we have 4. And repeatedly what we see is that glass has high impacts. And aluminum on the last one kind of competes there too. We'll also see that especially for the non-carbonated, that first PET example is also the one with the least amount of impacts, and across the board does the best. So I wanted to talk a little bit about the types of impacts we're looking at here. So on the top right, acidification, that's the release of sulfur dioxide into the atmosphere and can cause things like acid rain. Of course, that's a problem. And then on the bottom left, we have eutrophication. This is where you can have too much, in this case, nitrogen equivalents released into water, and that can cause algae blooms. Once you have algae blooms, that can remove the oxygen content in water and make it harder for basically take over the ecosystem and throw things off balance. And then the last one is water consumption, which is pretty self-explanatory. So this analysis is pretty clear that, plastic would be the least impactful. But there are many cases where you look at one measurement and it does the best, and then the same material does the worst in another metric. So these can definitely vary a lot depending on what you're looking at. Any questions so far?
I've got nothing in the chat yet, but you're doing a great job and definitely was different than my vote. So thank you for the information.
Yes, definitely. Data can contradict perception for sure. So next I want to move into sustainability goals. Given that we just saw with the life cycle analysis, there are different things to measure. There are different goals we can set for ourselves. So when somebody says they want to be more sustainable, what's their motivation? Another way to phrase this is, where are these pressures for change coming from? If you've had something that has worked for a long time and that it serves its purpose. Why would we put in more resources, maybe something that's more expensive, to make those changes and be responsible? So different approaches to this can come from the government, which can enforce these sort of changes. Environmental organizations will help bring, I guess, education and also influence consumers who can bring demand for these types of goals. And then businesses within the supply chain can also um, motivate someone to make changes in their packaging. I'll start first with regulations. And I will say it is something that is not easy to navigate, especially that Kwik Lok is a global company. We have 6 plants across the world, and we can have a law that's specific to just a city, a state, country. It all changes, and you can move just one town over and see something else. But some examples that you might see of regulations could be recycled content mandates, for example, where you have to include a percentage of material that has been recycled into certain types of products. There can be outright bans. So, one that's come up a lot is, for example, styrofoam packaging. And one that's gaining traction here in the US, even though that's existed already in Canada and Europe, is extended producer responsibility, or EPR. So, just within the past month, Washington governor signed packaging EPR into law. So, what is EPR? It is a system where brands who can choose the type of packaging they want for their products essentially pay a fee based on the type of packaging that they use. So, the goal here is to be able to fund recycling and disposal systems, but also motivate these brands to use packaging that can be more sustainable. And so, while there's still a lot of questions exactly how this is going to be run and implemented, it's a step in the right direction so that it's not just materials being released and not enough resources being put with how to manage it. There's also voluntary participation. So maybe if you want to be ahead and don't this and try to make strides ahead of situations where you need to, Kwik Lok has participated in and continues to participate in several plastics pacts in the U.S., in Canada, and then the Australia, New Zealand, Pacific Islands region. So the goal of these pacts is to keep plastics in the economy and out of the environment. So it's not just to remove them altogether, but really to use them more responsibly. And all of these pacts have aggressive goals to meet for 2030. This includes eliminating unnecessary and problematic materials, promoting reusable, recyclable, compostable packaging, and then improving recycling rates and increased use of recycled content. So I want to focus a little bit more on the first one and exactly how that has impacted Kwik Lok. Different types of plastic are not made equally. There isn't just one type, there are different types. That's what makes it so versatile. But only certain ones are really focused on for recycling, and those are the ones listed in here in green, 1, 2, and 5. Whereas the ones in yellow have very low rates of recycling and generally not considered recyclable. When Kwik Lok was established in 1954, polystyrene, or number 6 plastic, is the material of choice because of its properties. It does its job well, and we've been using it for decades. Now, it's only been within the past decade, really, that we've started looking at other materials. And this is because this number 6 plastic is considered a problematic material in these plastic packs due to its recycling rates and the infrastructure for recycling. So in 2019, Kwik Lok came out first with the Eco Lock. So this includes a starch additive. You see some corn kernels here. You can Starch can come from corn or potatoes. And so now we're introducing this bio-based material rather than just having something fully fossil fuel based. And moving on from there, we've continued to develop other closure options. 2022 was fiber lock. So we have paper-based options, a couple of different ones that can work in certain conditions. And then in 2023 was our latest release of the EnviroLock. So we've moved, this is a chance to move out of number 6 plastic entirely and into number 5 with a few years of development, formulation, testing. We're excited to be able to release the EnviroLock also. Now, with these different options, and we've seen that regulations can change, there are retailers and stores that will also have their own goals in place. And I wanted to talk through some of the ones that I've seen and some of the different ways you can address them through packaging. So somebody might be able to say, our goal in our store is to reduce waste. So as a packaging manufacturer, what you can do is down gauge or just make your material thinner as long as it's still functional. And that way you have less material going out overall. You can remove unnecessary components. So maybe if you're a bit on the side of making luxurious types of packaging, really rethinking what do you actually need and removing components that you don't. You can also choose materials that can be renewable. So maybe you can repurpose things. You can use recyclable materials. There's different ways to address your material choices there. Another common packaging goal example you might see by companies who set it is 100% recyclable packaging. Most straightforward way, of course, to address that is to switch to a recyclable material. You can also look at not just the components, but look at the packaging as a whole and make sure each part can work together. So if you have to, say, make your customers separate things out, do extra work, it's less likely to actually end up in the right stream. So making things simpler with the same types of materials that all complement each other is another way to do that. The third point here is to remove problematic features or additives. So you may have a material that is, for example, recyclable, but it has a part to it that won't do well in, say, a recycling system. You might have seen examples where green colored plastic bottles were changed to clear, and it might seem, well, what's the point of that? How is that sustainable? The thing is that white or clear colored plastic is the one that has the most demand. Not everyone will want to use green reused packaging. So different things like that will also impact recycling. And then another example of a goal could be responsibly sourced. So this could mean, are we using a bio-based material versus a fossil fuel-based one? It could be including recycled content. So not just making your own product possible for recycling, but actually completing that circle and including in their materials that have been recycled already. Another way to look at responsibly sourced materials is through certification. So mentioned in the beginning, responsible forestry for paper. And this goes through a certification process where it's not just your company making your goals, but there's different stages of the product are assessed and looked at to make sure that the way it's handled is appropriate. All right. Any more questions or thoughts before we move on?
I have a question in the comment. Yes, it says it's been said that 5 to 6% of plastics are recycled. How does Kwik Lok track the success of its sustainability packaging efforts?
a good question. Yeah, so the statistics for exact recycling rates do vary a bit. How does Kwik Lok measure our own? It's really hard to know how our own products do because there isn't a good tracking system. We do have to rely on data that comes from the sorters of recycling, and knowing what kind of restrictions they put on the types of packaging that does go through their systems. So if you were to ask, what is the recycling percentage rate of a Kwik Lok? We don't have a good way to measure that at this moment, but we could work directly with maybe a sorter, or really what we rely on is more like guidelines for packaging design to be able to meet those requirements. Does that help answer the question?
Thank you very much.
Okay. So speaking of recycling rates, there was a report that came out in 2023 that looked at recycling rates of the 4 different materials that I talked about in each of the states. You'll see here in teal, ones that have at least 40% overall recycling rates, and then ones with 20 or more in yellow. Washington was ranked 15. And if we break it down and look at each type of material, paper has the highest recycling rate, 67%, followed by metal at 41%, then glass at 27%, plastic at 11%. This includes both rigid and flexible, and that brings us to our overall of 46%. Now, when I look at that plastic recycling rate of 11%, I'm not impressed, and I'm sure you aren't either. And so this is something I wanted to talk a little bit more about. So, for labels and communicating to consumers of public about them, we have the chasing arrows symbol. While it's widely recognizable, there's been contentiousness about what exactly it means, and it has some vague messaging. So what's been done or attempting to be done is to make clear packaging instructions about what to do with your material. So in the US and Canada, there's the how to recycle label. So this will address each part by name. It'll say whether it's recyclable or not. And depending on where you are, you may or may not have recycling for a particular item. And so it'll have a check locally symbol. If there's any instructions like rinse before recycling, that's also included. Australasian recycling label also is similar, just a little different looking. In the UK, for example, there's also just recycle or do not recycle, and try to keep it simple. Now, because recycling streams vary a lot depending on where you are, and you do need to check locally. In Australia, there's the Recycle Mate, and in the US, there's the Recycle Check. So certain products will have a QR code on them that you can scan to check if you can recycle in your area, or you can just go to Recycle Check and type in your zip code and describe your product and see if you can recycle it or not. So moving on to our next Slido question, I want to propose a true or false statement. So given the low plastic recycling rates in the US, the best way to address plastic waste is with biodegradable plastics. So instead of trying to make people put them in the bins, if anything gets out in the environment, we can let it degrade. True or false?
The answers are still coming in. We were just at a 50-50 tie, so this should be
Interesting.
interesting. 50-50 again. I'll give it just another few. Okay, everybody get your last minute vote in. Okay, we're gonna end it at 57% true and 43% false.
All right. Okay, so I will lead you to our answer again. I won't say it what my stance
And
is.
we do also have a question.
Sure.
Sherry Lou is asking, she said a few years ago, the US sent all their plastic over to China as we did not have facilities to recycle plastic. Has the US built more recycling facilities that you know of?
One thing I do, well, recycling is definitely a multifaceted problem, and not all recycling facilities are running at capacity. And so this has to do with things like, is even enough plastic collected curbside versus not offering versus offering those services. And then once they actually do make it to those facilities, you have to make sure there's demand for it too. So not everybody wants to pay for quality recycled materials, or there has to be applications for um, wider spec, lower grade materials that can be used for other things. So it's a little hard to answer this question directly because there are several factors here. But what we do know is that we can recycle more with the facilities that we do have.
Awesome, thank you.
All right, so in my last question, I used the word biodegradable, and I also want to compare it to the word compostable because there can be some confusion here. The term biodegradable has, as much as it sounds like a great option, especially when you have bio in there, there has some drawbacks. So there are things that it doesn't include in its definition. And one of those is time frame. How long would it take for something to degrade? There have been companies that have gotten in trouble by using the term biodegradable for their products, only to go to court and lose because when a consumer thinks of biodegradable, they're thinking, maybe within a year or so. Whereas in some cases, depending on the material, it might take hundreds of years, and that's not acceptable. So biodegradable also doesn't account for what kind of conditions you need for degradation. Is there a certain type of maybe water content, temperature? How do we account for that? And then also we want to make sure that whatever is degrading actually turns into products that are safe rather than ones that can cause more problems down the road. In certain geographies, including Washington State, using the term biodegradable for marketing is illegal. So if you see the word biodegradable, take it with a grain of salt because it can mean very different types of scenarios. However, in the subset of that, we have certified compostable materials. So these address all these different these different points like times, conditions, toxicity, and there's a set standards that are tested by labs to certify something as compostable. So you might ask, well, how would I know if something's compostable? How can I find a way? Well, we have the chasing arrows for recycling, but the ones for compostability really aren't much better. There's definitely room there for clarity. Depending on where you are, there's different types of organizations, different types of labels. They can get kind of messy, but we definitely have a start by being able to define what compostable packaging means and how we can get it approved, and so that we can compare and say, yes, it will degrade or not degrade. So I wanted to also talk a little bit more about the composting process. When somebody thinks compostable, they may think, well, if it's just going to be in the environment, it'll degrade and it'll be okay. But that is not the case. Composting is not permission to litter. We still want to be able to collect it and process it in the right way. This image here is of a composter in Washington. And you can see that these compost rows are quite large in comparison to the trucks that you see there. And so together with yard and food waste and the appropriate compostable packaging, we can process these back into soil at commercial facilities like this. And so let's take a minute to compare it to, say, a landfill. If we have product, we'll take an apple in this case, put it in the landfill. Those are sealed. So that means they're not going to have oxygen aerating all that waste. And certain sets of bacteria will grow in it. And the products there are carbon dioxide and methane. Of course, this is over slow, lots of time takes to do this. And the methane is problematic because it's a very potent greenhouse gas compared to carbon dioxide, depending on which numbers you find. It's about 30 times more effective in the greenhouse effect. Now, if we compare instead composting, and we take our materials like an apple, where there is oxygen, there are even techniques that purposely aerate it, and we have different set of bacteria that can then process it into carbon dioxide, water, and then other nutrients that are retained in the soil. So we're not having that methane come through like we would in landfill. And so really with especially with yard and food waste, we can recover value. We can use this soil again. In landfill, we're not going to have that same value come back to us. So I have one last question. Actually, do I have this question listed?
No.
Okay, I will just use it as it is. You guys don't have to use Slido. All
I
right.
think I can add it really quick.
All right, if you're able to do that, that would be great. Sorry, I forgot to do that.
Okay, you're
All
doing
right,
great.
so I'll ask the question, read it out here. That is not the question I wanted to ask. Okay, let's ignore the question for now and just look at the graphic here.
Okay, we've got 5 minutes too left.
All right, so we're going back to the one that we had. Okay, never mind. This is one that we already asked. So given the low plastic recycling rates, what's the best way to address the waste? So let's take a look in this bigger cycle here that we have of the compost cycle. So starting the top with the orange arrows, we can have our packaging moving clockwise. The appropriate packaging can then be composted. From there, we create biomass or the soil, and then that can be reused at the bottom here for agricultural feedstock. Moving on, we can then use that as renewable raw material. So say if we had starch-based packaging, the growth of that corn or whichever material you have, you'll be able to reprocess back into resins and then make your products again. If we just recycle, we're kind of cut out a lot of these steps. We don't have to go back and make soil, regrow plants, reprocess it. We already have our materials. We just can recycle them that way. Does that make sense? You're shortening the cycle if you recycle versus if you biodegrade. If you have a box, you can put it into a compost bin and it'll make soil, grow tree, and you can use that tree to make another box. Or you can use the fibers you've already processed and process them again through recycling and be able to make your box again. So I think with this example, I hope I'm being clear. I would say recycling does not have to be, um, recycling can be the better option than degradable plastics because of how many more steps are involved if you go through biodegradation. There are definitely cases where that would be helpful, especially if we're talking about contaminated materials that have food and grease all over them. But recycling can be more efficient. Okay, I think that answers that question. All right. So to summarize what we've covered today, we looked at packaging materials, some of the basic science and their trade-offs. We've looked at environmental impacts and how that can be compared through life cycle analysis. And then we've also looked at different types of sustainability goals and the different directions we can take them. And then we talked about some product messaging with labels for end-of-life instructions. All right, thank you all for your time. I can now take questions and then I'll let you continue with your day.
So we've got a comment. Lisa says, I've learned so much on this webinar. Thank you, Victoria. Great job on presenting this important information that we can apply in our daily lives.
Thank you. I'm glad to be able to teach something new.
Okay, we've got just a few minutes if anybody has a last minute question. Okay, well, thank you so much, Victoria. Just to echo what Lisa had said, so much great information and um, and an eye opener to sustainability. So thank you for teaching us all something new. And I wanted to say to anybody that's still on, if you have any questions or comments, I'm going to be sending a follow-up email with a survey about just the event in general, and then feel free to reply with any questions you might have. Jody says, very interesting and informative. Thank you, Victoria. And you're getting a ton of thank yous. So thanks again, and it was great to see you all. Thank you for attending, and everybody have a great day. Thank you.
Thank you.